into your 20th OpenGL tutorial. So we talked about pipeline in the previous tutorial, and I'm gonna explain it right now very well so you can understand. As inputs to the graphic pipeline, we pass in a list of 3D coordinates, which you can see. We pass in 3D coordinates, so that's why I jot it down there. We pass in 3D coordinate that should form a triangle in an array here called a vectors data. So what we pass in is a vectors data. So this vectors data is a collection of vectors. A vectors is basically a collection of data per 3D coordinate. This vectors data is represented using vectors attribute that can contain any data with like, but for simplicity's sake, let's assume that each vectors consists of just a 3D position and some color value. So what, just get this in your head, that a vectors is basically a collection of data per 3D coordinate. 3D coordinate, we have 3D, that is a coordinate, a second coordinate and third coordinate, which form 3D coordinate. So in order for OpenGL to know what to make of your collection of coordinates and color value, OpenGL require you to hint what kind of render type you want to form with the data. Do we want the data rendered as a collection of points, a collection of triangle, or perhaps just one long line? Those hints are called primitive and are given to OpenGL while calling any of the drawing command. Some of these hints are GL points here, GL points, GL triangle, and line trip. So get out. The first part of the pipeline is the vector shader that takes as input a single vectors. The main purpose of the vector shader is to transform the 3D coordinates into different 3D coordinates. More on that later. Okay, and the vector shader allow us to do some basic processing on the vectors attributes. Okay, now the primitive assembly stage take as input all the vectors if GL point is chosen from the vectors shader that forms the primitive, and assemble all the points in the primitive shape given, in this case a triangle. So the output of the primitive assembly stage is passed to the geometric shader, which is passed to the geometric shader. The geometric shader takes as input a collection of vertices that form a primitive and has the ability to generate other shape by emitting new vertices to form new or other primitive. In this example case, it generates a second triangle out of the given shape. So in the next tutorial, we'll talk about the output of the geometric shader. Then we'll talk about the fragments, and so see me in the next tutorial, and don't forget to subscribe, like, and share my videos. You can comment. So bye for now. See me in the 25th